Okay, I think we can get started. Welcome everyone. Good morning, good afternoon, wherever you might be. My name is Frederick Winsness and I'm with NetHope and with the NetHope Solutions Center. We are thrilled to welcome you today to yet another NetHope Solutions Center webinar series. Today we're here to hear about using IoT devices to gain insight into network challenges. And we'll be hearing from NetBeez in a few minutes. Before I introduce the speakers, I want to go over our normal housekeeping rules. We do want to make this as interactive as possible, so please do line up your questions in the chat window. So I would suggest opening the chat window right away to monitor the chatter there or the traffic. And so if you line up your questions, we'll be facilitating a Q&A session at the end of the hour today. We're recording this, and you'll find the recording as well as the presentation on the NetHope Solutions Center later on today or tomorrow. And we'll send out an email with the points to that information. And at the very end of the session today, you will be presented with a webinar satisfaction poll, and we certainly would appreciate you spending 1 or 2 minutes filling that out for us. So without any further ado, I want to introduce Duncan Drury. Duncan is with NetHope, and he's with our Connectivity and Infrastructure Working Group. I'll turn it over to you, Duncan, for some opening remarks and to introduce the speakers.
Series of Connectivity and Infrastructure Working Group webinars. Today with NetBeez. I'll tell you a little bit of a story about why I found NetBeez particularly interesting and invited them to come and talk today. So when I was working at Christian Aid as a networking engineer, I really got into network monitoring, first of all using a system called Nagios. I found a limitation of that, as much as I loved it, was it never really let me understand what the local experience was like in Christian Aid's offices around the world. And particularly, it never really answered any questions relating to bandwidth. So I knew everything about the network, but I was never really able to answer the question, why is my connection slow? So more recently, I was chatting to Mark Hawkins from Save the Children about this, and I asked myself and him, couldn't you just use a $25 Raspberry Pi to monitor remote networks? A quick search on the web quickly turned up NetBeez, who'd already perfected the art of this. I tried it out, thought it was pretty good, and thought, yeah, this would be really interesting to other NetHope members and other people in the NGO community. So invited Stefano and Alex from NetBeez to share their product with us today. Stefano?
Awesome. Thanks, Duncan. Appreciate it. And just wanted to say thanks for everybody for joining. My name is Alex. I'm an account manager here with NetBeez. My responsibilities include conversations with new customers, building the business, and presenting use case scenarios, talking to folks just like you all over the globe. And then with us today, we also have Stefano Gradelli, who is one of our co-founders as well as our CEO.
Thank you, Alex, and hi, everybody. Really excited to tell you more about us and NetBeez.
Awesome. So first and foremost, would like to just give you a little bit of background on the company, on NetBeez, who we are, where we came from. We were founded in 2013 in Pittsburgh, Pennsylvania. We have 2 office locations in the United States. Here in Pittsburgh is our corporate headquarters, and we also have a remote office in San Jose, California. The founding team were a network engineer, which Stefano Gradelli was prior to starting his responsibilities here at NetBeez, as well as 2 other co-founders that are computer science PhDs. And what we are at a core, what we do for organizations all throughout the globe already, such as yourselves, is network performance monitoring from the user perspective. So what does that mean? Really, we have a variety of sensors or agents, whether they be hardware or software or virtual based, that can be installed into various portions of the network at remote locations in distributed networks, and run tests as a network engineer would at those locations on that network, simulating user activity and then feeding that information back to a central location, to a dashboard, for a network team or IT team to really be able to gain valuable insights on those remote locations, and do some one-off troubleshooting, configuring, and just complete overall visibility from our central dashboard. So we do have some initial investors that kind of bought into the idea. Carnegie Mellon University right here in Pittsburgh, Pennsylvania, as well as Y Combinator, Partech Ventures, and Innovation Works. Were a couple of folks that really saw value enough into us to invest. So at this time, I'm going to kind of pass the ball off to Stefano and let him explain a little bit into the background of what he wanted from NetBeez, where he came from in his prior life, and where he saw value in the idea of NetBeez as a whole.
So when I was a network engineer, I found very difficult to detect problems and troubleshoot the problems. Just to give you some background information, I was supporting for a healthcare system hundreds of remote offices, physician offices, hospitals, and really realized as a network engineer how difficult it is to detect problems experienced by remote users at those locations. That was the #1 problem. The second is like troubleshooting remote issues, whether it's a network and application problem, was very time consuming, and kind of a collaboration sort of deal where you open a conference bridge, network engineers, remote users, the application team joins the call, trying to figure out what is the problem and collect as much information as you can. And it's not that we didn't have the right tools in place, like SNMP and NetFlow is almost everybody has at least an SNMP or a NetFlow tool, because SNMP is great to detect problems with routers, switches, get information about those network devices. And even myself, before being a network engineer, I work on Zabbix, Nagios, and those tools are great, but they don't really give you information whether user can connect to the network, to the cloud application, and what's right now their latency, are you experiencing any packet loss, and so on. NetFlow on the other side gives you like accounting information of your flows, but they really are not proactive, because passively they just tell you what they see on traversing a router or a switch or a network link. So with that, like a first-hand experience, we really, me and my co-founders, Panicos and Panos, while I was a network engineer, as Alex said, Panicos and Panos were PhD in computer science and computer engineering, so they had experience with building actually a distributed system, and of course coding on embedded system like the Raspberry Pi that we'll see next. So we really team up, and we decided to solve this problem, not because we want just to launch another network monitoring tool in the ecosystem, but because we really wanted to solve this problem of detecting problems before users do. Another problem that network engineers keep running into is like validate configuration changes when you have to deal with a large wide area network, as probably most of NetHope members deal with every day. So configuration changes that impact, for example, firewalls or routing policies and so on. Those are changes that sometimes may cause glitches or connectivity issues between locations or to the internet, and they're very difficult to detect with SNMP and NetFlow. So that's where also we envision like an active monitoring system, sensor-based, like a NetBeez, that would continuously probe the network and the application, and could be also be useful to validate post-configuration change that everything is working out. because when you have hundreds of remote locations, the other option is either you telnet or SSH at each remote host, just one host per location, and verify that connectivity is working, or you wait, next day 8 a.m. if you apply the change at night, and you wait for the end user to detect your problems, and of course nobody wants that. So this is like the core idea of NetBeez. And 4, it just also the timing was right. In 2012, the Raspberry Pi came out. If you're not familiar with this platform, is produced, developed, and sold by the Raspberry Pi Foundation, which is based in the UK. And this Raspberry Pi was really, I would say, a kind of a revolution for computing, because the original goal of this platform by the Raspberry Pi Foundation was to provide computers cheap and powerful to a nation that couldn't afford like expensive desktop or laptop computers. So maybe in the African region or other part of the world. And this like Raspberry Pi, this platform is equipped with an ARM processor. The first version, I believe, was 1 gigahertz, which is pretty good, half gigabyte of RAM, and 1 Ethernet interface. So really, when we got like running into this platform, we said, wow, we have now an option to really build a distributed network monitoring solution that relies on small and cheap hardware sensors like IoT in the end, and this can be deployed at scale in dozens, if not hundreds or thousands of remote locations. So we have that visibility kind of from the remote side, from the end user perspective, into the network and applications. So really, like, the timing was right. NetBeez was really founded in 2013, so a few months after the advent of the Raspberry Pi, which now is, I think, is the 6th anniversary. And as you know now, this platform has made great progress. They increase, I think the CPU now has a 4-core ARM, I believe 1.4 gigahertz, the last version. It has a gigabit Ethernet interface, which can push up to 300 megabit per second of throughput, and has 4 USB. So really a great platform to build NetBeez.
Great, thanks, Stefano. And so typical users of NetBeez, how they utilize our tool within their network and what they use it for, first and foremost, is really detecting problems before the users do with proactive alerts. And one of the things that really differentiates us from the standard types of network monitoring is we're not just going to tell the network team when a device, a switch, or a router is on or off, or an application is on or off. We're going to give performance metrics based on whatever configured SLAs or performance SLAs that organization has, and those alerts are going to come in real time to the dashboard, and either connect with current integrations with PagerDuty, Path Solutions, Splunk, Slack, or your SNMP, SMTP, or syslog alerts to immediately get notification of any performance issues that are in the environment. Usually there is notification being sent to the teams within 5 to 25 seconds, as opposed to 15 to 30 minutes, if not sometimes days, before realizing that there is a performance degradation issue on the network. The other thing that we do is help identify the network versus application issues, and this is a huge issue for network engineers today. And tons of time is spent and wasted in determining whether an issue lies on a network at a particular location or globally, or whether that issue is within a particular application or series of applications or something else. So very quickly, and we'll show you in our dashboard demo a little bit later, how we really very quickly, almost immediately, can tell you where an application, where an issue, actually a network issue, issue is, whether it's on the network itself or it's within a particular application. And this just aids in proving whether it is or isn't the network, right? And we do this with the real-time and historical data. And again, just to retouch on what Stefano said earlier, which was validating any kind of configuration changes and letting the network team know that once a configuration is pushed, whether that affected negatively the network as a whole globally, or whether it was one location or a series of locations. So what are our typical customer base like today? Well, we've seen some giant traction in healthcare, higher education, nonprofits as well. We also have some rather large, not to be named here on this webinar, organizations that all of you would definitely know that are currently utilizing our solution today for that exact reason, and that's greater visibility into how their users are experiencing the network at very large, globally distributed networks. So where does NetBeez fit in the traditional network monitoring stack? So in your traditional stack, at the core, you've got your switches, you've got your routers, and those are monitored by your SNMP, such as like PRTG or SolarWinds, and they do a great job of telling you when there is a hardware malfunction, when a router's not working properly. They're going to give you that detail, but they don't give you that detail on the users. They don't give you the information and the statistical performance data on how your users are experiencing your network. That next layer, NetFlow, is great for understanding, some top talkers and statistical utilization. But again, it's passive in nature and it's not very active detail. And you're not really going to find out that there's an issue until your users have already experienced that issue. Now, where NetBeez sits, again, with our sensors, whether they be hardware-based or software-based or virtual, they sit on the edge of the network and they simulate user activity. So they essentially are simulated users on the network and feeding that active data to the networking team, giving, again, the real-time alerts for you to be able to proactively go and maybe head a network issue off at the pass a lot of the times before the users will even experience or notice that there is a glitch in the network performance. So at this point in time, I'm going to then pass the ball over to Stefano for an overview on really the back end and how we do this.
So the NetBeez architecture is based on a client server. What does that mean is that we have the agents, or the clients are the sensors. Whether it's a Raspberry Pi, it's a virtual agent or a software agent, they are the one that connect back to the server. The server is the dashboard that we'll show you later in the product tour. The important thing to keep in mind is that the NetBeez server doesn't do any monitoring. See as if it's the kind of controller of the agents, the data repository, and the kind of data analytics processor. The agents are the ones that do the monitoring. And that's why we call it distributed network monitoring, because the tests are initiated by the agents. And the test results are then sent real time back to the server for processing. So the beauty is that really you configure a test, push it to the agents, and then you see immediately the result on your dashboard. To be a little more detailed, the agents will have to connect to the server via, by default, port TCP 2018, but of course this port is customizable and can be changed on a per instance basis. Another thing is that the agents are pre-configured with DHCP, so they're really plug and play, because most of our customers, they have dozens, if not hundreds of locations, so they don't really have time to configure their own Raspberry Pi. So you just like plug them, get a DHCP, and connect to the server. The server can run on-premise and will be delivered as an OVA or virtual appliance to you if it's on-prem, or it could be installed as a cloud instance, whether it's in your cloud or managed by us. And if you don't want to manage the server, that could be a great option. So all you have to do is deploy it or ship agents at the remote locations. And NetBeez was built, of course, to scale not 5 or 10, but really dozens or hundreds of sites, because most of the companies that we deal with, they really have a pretty large footprint, either nationally or worldwide.
Great. So how is the deployment done? So the way, and just kind of touch on what Stefano was saying, these hardware or software or virtual agents are installed in various places throughout the network, remote locations, data centers, in the cloud itself, and then track that performance data and sending it back to the dashboard that we'll go over in a minute. Once those devices are installed, then the monitoring tests are configured within the dashboard, and then the real-time alerts are gathered and can be viewed in the dashboard. The types of sensors that we have, just to touch on this a little bit further, is we've got the hardware agents, which again are based on the Raspberry Pi platform. We've got our fast Ethernet and our gig Ethernet. The fast Ethernet is great for any bandwidth testing that's below 90 megabits a second, and then the gig is great for any bandwidth testing that would need to be done below 900 megabits a second. You can also install a software agent or a virtual agent on your own hardware to get any kind of throughput tests above that to see what your max throughput would be. In addition to the Ethernet agents, we also have Wi-Fi sensors, and we'll go into more detail in the dashboard on the specific statistics that these sensors can pull from the wireless network. And then I'll let Stefano touch base on the software, virtual, Linux, and cloud agents now.
Software or virtual or cloud agents are great because for ease of deployment, but they also have a specific use case. The virtual agents could be delivered as an OVA or a KVM, and they're great first and foremost for data center environment. As you know, the primary use case of NetBeez is, of course, deploying a sensor at the remote offices. But by deploying a virtual agent at your data center, you can first check that remote sensors have connectivity to the data center, validating kind of remote location connectivity to the data center in the end. But also they can check that the infrastructure, network infrastructure at the data center itself is working correctly, inter-VLAN traffic is working, and internet access is working. So we see always more leaf and spine and networking vendors going towards an open model where hardware and software is decoupled. And most of these like open white boxes solution, they rely on a Linux operating system for the kind of software part or operating system part. So we also have the Linux agent that you can easily install on any Linux host, whether it's a router, a switch, or an existing server or Linux host. And the last one is the cloud agent. It's an external agent that can be installed in any public cloud because they all support Linux. So whether you have AWS or Azure or any other public cloud, you can have the kind of external / internet perspective into your cloud app, web app, or third-party site. Even your own website. You don't want to monitor your website from your internal network or from the DMZ, but you want to monitor from outside your network. So that's another use case, and also another very important thing is that if you have a connectivity or performance problem to an internet application, you don't know if it's really limited only to your enterprise network or common across the board. So the cloud agent really gives you that kind of external perspective into your network and application performance. And another thing to mention is that, as you see the small logo on the bottom right, we're Cisco Preferred Solution Partner. What does that mean is that our virtual agent was certified by Cisco to run as a virtual service on the Cisco ISR routers. So we have more information about that specific agent on our online documentation.
Great, thanks, Stefano. And then the types of tests that we're running on these sensors are displayed here on this slide. And so what we really tried to achieve was the reduction in time that it took network engineers to get to the end answer by doing these very tedious manual tests. So ping, DNS, HTTP, and traceroute are the 24/7 tests that can be configured on the agents to the targets, gathering detail both on performance and connectivity and filtering that back to the dashboard. Again, saving time and energy in the long run. And I mean, imagine it like this. You've got remote locations all over the globe. You may not have technical resources at those physical locations that can run these types of tests on the network there. And if there is performance issues in connecting to that location, you may not even be able to run the tests from your central location where your IT team is housed. So with the agents, you get the ability to have almost a network engineer that's there at that remote site, continuously running these tests on the network and then feeding back that metric data to your dashboard in real time. Also, to touch on, each agent itself has an interactive agent console that will give the network engineer and the IT team the ability to SSH into that agent and run some one-off configurations or tests on that network from the dashboard through the agent. So again, we tried to limit the amount of maybe travel time needed or local resources that were needed to be brought in to troubleshoot the various network issues. Then we also have 3 scheduled tests, our iPerf, VoIP, and speed tests, which are great for giving you throughput, jitter, and packet loss overall on the network there. And then VoIP is giving us the mean opinion score. It just averages it and just to let you know call quality and things of that nature. And this is all visualized on our dashboard, and our dashboard is really designed with the NOC, the Network Operations Center, in mind. It's very simple, intuitive, it's very easily manageable and easy to navigate through. And Stefano here in a second is going to go through an actual dashboard demo to show you how you can prove it's not the network, how you can gather this detail, what it looks like there within the dashboard. Before he does that, some of our most common use cases are, as you see here, remote site monitoring, Wi-Fi performance monitoring, and end-user experience monitoring. For remote site monitoring, we're going to look at things like internet bandwidth. We're going to look at network performance to the cloud. And again, this is done, with the idea in mind that the sensors are operating as clients on the network at those remote locations, and then feeding you that performance data to your central location so you have an overview and an understanding of how your users may be experiencing the network at those locations. And then we also have a public API that you would have the ability to pull the data from the dashboard and build a service around it to give you that overview of the network as a whole, if that's something that would be interested in as well. We also do Wi-Fi performance monitoring, and we're pulling information such as signal strength and coverage issues. We're also giving information on SSID availability and performance. And then overall, the end user experience monitoring, we're checking HTTP availability and performance, as well as DNS availability and performance, and VoIP performance through the mean opinion score. At this time, I'm going to pass it over to Stefano, and he's going to give you guys a live demo of the dashboard.
Thank you, Alex. So let's see how the dashboard looks like, and happy to show you a little more information and details about the kind of NetBeez workspace. So I will now share my screen and switch to the dashboard, if you can see it. Let me go full screen here. Here, okay, very well. So I think you can, let me double check I'm sharing the right slide. Okay, it's always like technology sometimes. Very well. So what you can see here, this is like the main view of the NetBeez dashboard. The very first view, we call it the bus tab. As Alex was saying, is nothing more than the knock screen where users can log in, maybe leave it on a screen in your knock and see what's happening in your network. The first information that we want to give you with the current network rating is 1 to 5 star, the status of your network. 5 stars clearly is good. The less the number of stars, and the more the problem that you might be dealing with. Then we have like 2 donut charts about agents and targets. So in the NetBeez jargon, an agent is a sensor that you deploy at the remote site, and the status of that sensor reports gives you an information about the network location where that sensor is deployed. The target is, in the end, a service or an application or a cloud app that you're monitoring with your sensors. So in this case, we don't have any problem at remote locations because all agents are green and we don't have any incident. While on the target side, you can see that one target has an ongoing problem. So if you see here at the bottom, we have agent incidents and target incidents. You can see clearly that there is an ongoing incident with this generic cloud app. And then if you click on the incident, you can get more details into what are the tests that have detected problems with that specific app. So you can see that we're having problem ping and HTTP-wise for that cloud app. So we can drill down later during the product tour. I want to just give you now an overview of the dashboard. In the middle section, you see agent and target performance. The agent performance is captured by the number of alerts triggered by the agents in the last 24 hours. You can see that the majority of agents are good. There is here an outlier on the top right with more than 600 performance alerts and 500 critical alerts. So this is a very a specific problematic agent, which is a Wi-Fi agent, as you can see, because I click here on the dot. So alerts and incidents are 2 different concepts. So an alert is triggered by a test like ping, DNS, HTTP running on an agent, while an incident is an aggregation of alerts either under an agent or under a target that really gives you that information whether it's a network or an application problem. The target performance on the right-hand side will give you information about HTTP response time average for the last 24 hours. You can see that here we have a different section or categories or of response time. Most of the targets fall below or equal to half second of HTTP get time. Then we have one that is between half and 1 second, and one target that is between 1.5 and 2 seconds. Moving next, on the Agents tab, you can see all the agents deployed on your network and managed by the NetBeez dashboard. You can also see on the bottom left here the counters. We have 25 agents with a 0 unreachable, so that's good. All agents are up and reporting. If there were agents down, you would see them here being unreachable. And the agent types, you can see here from this icon, whether it's a Wi-Fi, it's a virtual, it's a software agent, Gigi, Fasti, and so on. So by clicking on an individual agent, you can see, for example, a Fastitnet. This is based on the Raspberry Pi. You can see at a glance what is the availability of that agent for the last day. Then, of course, you can increase or reduce the kind of historical window or average. You can see the IP address. As Alex was saying, by default, they come pre-configured with DHCP, but then you can manage the agents through the interface management, set a static IP address, or change other configuration settings on your agent. If you scroll down, you see all the tests that agent is running. You can see that most of the tests are running green, so that's good. We have a bunch of ping tests to different targets, Salesforce, Google, and so on, and then other tests. So if you click here on any test, you can see the real-time data for the ping test in that case to Salesforce or to Google. So that's very useful information if you think when you want to know if there are ongoing problems on the location, or just be curious to see what is the latency from all your locations. You can also, of course, then generate reports, but you have immediate access to this information in real time. If you click on history, you can not only see the real-time information, but you can also go back in time and say, what was the latency or packet loss on April the 4th? And there you go. Based on your data retention period for configure on your server, you can easily review that information. So if you're troubleshooting a sporadic connectivity issue or some performance issue, you don't have to be on site. You have the sensor that will run, test, and then send the data to the server, who will retain the data at your for your review. And that's something that is typical. Even myself, when I was an engineer, you maybe work on a ticket and then complain that yesterday or last week the network was bad, and unfortunately you don't have any information there for you. But with the NetBeez, really you have access to that information. We will also provide an interactive console to the agent. So if you want to run some custom commands that you don't have integrated with the dashboard, you can do that through the interactive console. Let me show you also, the rest of the agents are very similar, like whether it's a virtual agent or a fast Ethernet hardware agent, the look and feel is really the same. The little special agent is the Wi-Fi agent, Pittsburgh Wi-Fi 2, for example. As you can see, this agent is special because it has two interfaces, the WLAN 0, which is the Wi-Fi card, which is used to run tests on the network. And then there is the control interface, which is the Ethernet, which is not mandatory to be connected to the network, but if you have the Ethernet connected on a Wi-Fi agent, if the Wi-Fi is choppy or flaky, you can still have a stable connection to the agent and get continuous data. So really, it's a two-interface agent, but in this case, all tests, no matter what, will go through the WLAN 0. So if that interface goes down, all the tests will fail. So it cannot do monitoring both on Wi-Fi or Ethernet. It will only do monitoring on WLAN 0. And as you can see, if I scroll down, the look and feel is the same kind of information. So the benefit is that really you can compare this information with an Ethernet agent and really see wireless versus Ethernet performance at a remote site. So if users are complaining that they have bad application slowness or low transfer rate, you can see if this is only limited to your Wi-Fi network or common across the Ethernet and the wireless network. So most probably could be maybe an ISP issue, an uplink issue, or an internal Ethernet problem. We have more tabs here, of course. The wireless gives you insight into the link quality as provided by the driver of the card that we use, which is an Asus AC56. So it's an AC card, dual mode, 2.4 and 5 gigahertz. And then we have the signal strength, the bit rate established with the access point, the channel number, and the BSSID. So all useful information to understand how your Wi-Fi network is performing, on what channel your agent is connecting to, and so on. And you can also force your agent through the interface management to connect to a specific band, a specific SSID, channel frequency, and so on. And we support EAP or 802.1x radius authentication for Wi-Fi network. You can also run SSID scan, and also here you can access the agent interactive console. Moving next to the target. Targets are application. As we were saying, you can see there is an ongoing incident to a cloud app. This is like more a stage incident for demonstration purposes, but you can see that we have all the agents. You can see here the total number of agents monitoring that target, and they are all reachable. But you can see that in the ping bar, or in the ping test, all agents are having performance issues because their test status is orange, and you can see that their latency is very high, and that's most probably causing HTTP performance issues as a consequence. So this is how really we can quickly understand network versus application issues. If you have problems only on a sensor to applications, then it's most probably a network problem. While if all the sensors are giving you problems to a specific app, then you have enough eyes in the mix, enough reporters in the mix to really say, I have a problem with my app. So it's all about fault isolation in the end, on top of having real-time and historical data for troubleshooting. And creating like a new target is very simple. If I say want to create a monitoring test to the NetHope website, I click Add Resource, and then here I define the actual URL, nethope.org, and then click on ping, DNS, HTTP, and traceroute. So these are the tests that I want to include in my target. We have default settings such as default intervals, but you can also change advanced settings such as, for example, for traceroute, you want to do a TCP traceroute to port 443 for HTTPS, or the HTTP test must be secure on the secure socket layer, or you want to add a proxy information. So once you have tuned your test settings, you select the agent, select just all for, and then you have the alert profiles. So this is a little more advanced, so we can explain maybe during a demo or find online documentation about it. I disable now SMTP alerts, click Save, and there you go. A NetHope, target is created, and tests are pushing real time, as you can see, to the sensors, and they will start immediately feeding information to the dashboard, like in real time. As you can see, I'm already like have a sensor in the Hague in Netherlands, one in Paris, one in Pittsburgh, and I'll start getting data. And you can see how each sensor has a different round trip time and different packet loss, because each network is unique and special. So this is how to create a target very briefly. I don't want to take too much time with this product tour, but other important parts that were always asked during the demos are the schedule tests. So if I go under iPerf, a schedule test is a little different from a ping, DNS, HTTP, and traceroute, because ping, DNS, HTTP, traceroute, generally you want to do it every seconds or maximum minutes, while because those are real-time monitoring, you want to be very immediate and very quick to find problems. While scheduled tests, because they run throughput tests on your network, you want them maybe to run once an hour, twice a day, or once a week. Generally, like once an hour is reasonable. So as you know, we integrate iPerf in our dashboard. We can support TCP or UDP-based iPerf. Could be agent-to-agent or multiple agents to an iPerf server to test like point-to-point or multi-point to one location throughput test. We have speed test. While iPerf is kind of location to location, speed test is a download and upload speed to an internet speed test server. We support the UCLA server, and we'll support in the next release also the NDT by the MLabs measurement. You can find also that speed test on the Google homepage if you type speed test. And the last one is a VoIP. As Alex was saying, we can generate VoIP, simulate a VoIP streams between any two agents, and then based on jitter, packet loss, and latency, we'll give you a mean opinion score calculation, which reflects the call quality of your VoIP calls. Just one more minute before maybe we move on to the next part of the webinar. It's just the reports. You have the ability to generate reports. You can generate a network status report. You can generate a report based on agents, targets, or scheduled tests. You can have those reports be delivered to your inbox by scheduling automated reports. They will be attached as PDF, but you can also from the dashboard export them as PDF. And for example, the network summary gives you an overall overview of all your agents and targets configured. With that, I think probably we have given you a good enough product tour at the moment, so I'll leave it back to Alex.
Awesome. Thank you, Stefano. So how are we priced, and how are we really utilized there? This would be for their network enterprise edition. It's an annual recurring subscription. Pricing is per agent, per type of agent, and it's volume based on the quantity. There are different discount tiers. This includes, our enterprise pricing includes on-premise server, hardware and software sensors. It also includes support There are additional charges that apply for a cloud-based dashboard based on the quantity of agents needed because we're utilizing our cloud and our resources for that, but there is no additional cost for an on-prem OVA. And then the starting quantity for agents on an enterprise solution is 5. We do have available discounts for NetHope members, and we will leverage some discount for any webinar attendees today. If this is something that anybody is interested in, then you can feel free to email us at sales@netbeez.net. If you do want any additional information, we have tons of great documentation as well as our blog on our website, netbeez.net. And you can even give us a try with our free instance on your own Raspberry Pi by downloading an image. You go and you can fill out a form on our website, and we can get you spun up with a 30-day free trial if that's something that you would like to do as well. So at this point in time, we're going to have some question and answers. I did see some questions come through, and we're going to pass it back to, I believe, Frederick.
Hi, yeah, thank you very much. This is super interesting. Can you hear me okay? Yes. So, yeah, I think people are itching to get their Raspberry Pi and download that test image and get going. And I'm also very glad that the test that you did against NetHope.org servers went real well. So, and I didn't know you were going to do that. So that's encouraging that worked well. Let's take some of the questions from the top. The first question that came in was, what are the key network data you captured that you cannot get from networking gear? And can your solution interact directly with networking equipment to update configuration settings?
I'll take this, and thank you, Frederick. So network equipment, generally, some network equipment like think about IPSLA on Cisco routers. They can do some of the tests that we can run on the agents, but there are two things to consider. First of all, you don't want to overload with too many tests a router or a switch. Second, you want to do tests from the kind of user layer, from the access layer, rather than maybe from a core or from the kind of network device perspective. And third, you want something that is very easy to configure, easy to maintain, and where you can quickly and easily process the data in reporting, do trend analysis for proactive performance degradation. So not necessarily all data that tests that we run on NetBeez are implemented in all networking gear. But even if so, it's also about from what location, from what perspective you want to gather that data. So the second part of the question was if we can interact with networking gear. So as said before, we have always more networking vendors. Even Cisco are moving towards a kind of decoupled hardware software stack. And most of these vendors are employing a kind of Linux-friendly, a sort of Linux operating system. So you could potentially install a NetBeez agent, like in the case of the Cisco SR router, on this networking gear. At the moment, we don't have a way to update configuration of this network hardware, whether it's a router, a switch, etc. But I'm sure our kind of vision from a product perspective is also in the future to really start interacting a little more with the network hardware.
Excellent. You did touch a little bit on pricing and things like that, and obviously that comes with some discounts you mentioned, and people should contact you. But the other part of the question that came in early was, what about your support structure? Do you have do you have a support desk, or do you have field agents, or do you have a channel, sales channel that people can take advantage of if need be?
Right. So there are kind of two types of supports. in the picture. So of course we have a support number 24/7. You know, if we work with partners, they often, and we do support. We have partners. We work with either national or international partners. So if we work with a partner, generally they provide the first level of support, and then the partners will escalate the tickets to us. And there are also two types of support. It's either you need support with the general management and administration of your network location, or you have a specific support issues with the actual NetBeez solution. But to conclude, yeah, we have support either in-house or also we work with the partners, national and international, for this.
Excellent. I'm wondering if Duncan had a question. Did you want to jump in,
Yeah.
Duncan?
I'm interested in the Raspberry Pis, making them as plug and play as possible, because quite often NetHope members have remote offices where there's no member of IT staff based at the office. But sometimes we'd like to get these things out there and get them up and running as soon as possible. One of the things, one of the questions I had was whether there was a possibility of using power over Ethernet to power the Raspberry Pi, so they just have to be plugged into a network device that has PoE.
Gotcha. Yeah. So we do offer PoE with devices. That is a capability that we have, and any of the hardware that comes from us comes pre-configured to the server. So they're very literally plug and play with Ethernet and power. So there is, you know, the thought behind that was that these are going to be going into most of the times remote locations that may or may not have technical individuals on staff there, so you can very easily ship a hardware agent to a remote location and just have the staff there plug it in, and it'll automatically start connect to the dashboard, and you can configure your tests and targets from there. Great.
Another question is, how locked down is the operating system on the Raspberry Pis? Could these also be used for other purposes within, you know, within the network?
Yes, a great question. We're not open source, but we are an open platform. So the Raspberry Pi that can pre-configure from us, you have access through the interactive console if you are an administrator on the NetBeez dashboard, so you can really kind of do whatever you want with it. Of course, try not to break it, to limit, like, you know, make sure that whatever change you do on your Raspberry Pi, it doesn't impact the actual NetBeez agent that is running on the operating system. Or in alternative, we have a Linux package. What does that mean is that you could have NetBeez running on your customized hardware, Linux-based, and really do integrate, you know, Linux with some other tools, etc. So we're pretty open on that.
That's great. And then from the other side, there was a question about similar to that one. Had a second part that was, can scripts run on the Raspberry Pi for other things? Is it possible to have them feedback data to your dashboard?
Great question, and actually what we call the custom command. Right now you have access through the interactive console to the CLI, to the bash of the Linux. The data will be, not currently, we cannot currently get that data and feed it back to the dashboard, but it's in the roadmap to have a custom command, so you can basically give in as argument when you configure a test the name of the script, and then basically you pipe as the output, whether it's an integer or some text. So on the roadmap.
That's great. That's great to hear. Another question around collection of user data. Lots of NetHope members use Cisco Meraki, which collects quite a lot of data about what's going on the network, and I was interested to know whether NetBeez is gathering any additional information. Sort of a privacy question, I think.
Yeah. So I guess they're asking if we can collect data from Cisco Meraki infrastructure.
No, I think it was
more data data similar to what Cisco Meraki actually does in terms of some user data and to what extent do you need to be careful about that data because some of it becomes personal identifiable data?
Right. So since like NetBeez, the NetBeez sensors are like end user client, we don't do kind of packet capture traffic analysis. So we don't really see whatever is going on the network like from a NetFlow tool, because we're just another device in your network that is monitoring from the user perspective. Of course, we have a Wi-Fi profile that the NetBeez administrator has to pre-configure for the Wi-Fi agents, for the Wi-Fi bees. But no, the only data that you see is your own data, your own traffic that you generate. We don't do kind of packet capture or traffic interception.
Okay, that's great. That's very reassuring. There was a question came in regarding a tool called Netalyzer. I'm not that familiar with it myself, which was being used to analyze a user or an office's internet connection, but it's no longer maintained. Are you familiar with this, and do you consider NetBeez to be a replacement for what that tool did?
So I don't have first-hand experience with Netalyzer, so I cannot do a kind of feature-by-feature comparison. Although we can take this offline. For sure, like a NetBeez use case is remote site internet connection verification and troubleshooting. So I would say yes, but of course to do a kind of feature-by-feature comparison, we can take that offline. But bottom line, yes, I think, and that's our primary use case, is like a verification of internet connectivity, internet throughput, and so on.
Great. Okay. Yeah, maybe take that one offline, and we'll get back to the person that asked that question, and maybe get more clarity on what they were trying to find out. So one of the use cases that I see with a tool like this is holding our suppliers to account. So we often work with a very large number of ISPs, quite high cost, and we would want to hold them to service level agreements, which are usually based on things like uptime over a month or the average packet loss over a month. And I was wondering whether the reports that you've got would support this kind of thing. Can we kind of put our SLAs in and have the reports based around the SLAs?
Yes, actually, that's a great use case, as you brought up, of SLA enforcement with internet service providers. We actually have one, comes to my mind, one specific customer is a local nonprofit, and they were able to use actually NetBeez data to show their internet service provider for how long their network connectivity was down, and they could prove that it was not just a local area network problem, but it was a ISP issue. So as a result, they share with the internet service provider the historical report for the internet connectivity, and then they got also reimbursement by the ISP for that outage. So great use case.
Fantastic. Thanks so much, Stefano and Alex. We're reaching the top of the hour, so wondered whether you had any last-minute comments that you'd like to make.
No, I mean, if anybody's interested in seeing some more of the solution, we do personalized demos, customized demos based on your particular use case. Would be glad to, hop on a call using Zoom meetings and just seeing if it would make sense to get implemented in your organization. But we appreciate you guys. Thank you so much for having us today, and we look forward to maybe doing this again.
No, thank you so much, Alex and Stefano. That was great, and I think it's a really interesting tool that would really fill a gap for quite a lot of our members. So thank you so much.
Well, thank you very much, all three of you. Thanks, Duncan, for organizing all of this, and for Alex and Stefano too for an information-filled hour. We want to also thank the audience for some excellent questions and great interaction. It remains for me to ask you to please fill in the webinar satisfaction poll that you'll see that pops up on your screen when you leave the meeting today. And I wish everybody a great rest of your day, and we'll see you back here again soon for the next webinars. Take care. Bye-bye, everyone.